Okay, so hello and welcome back. Now in this video, this is chapter 8 of class 2, and we want to essentially in this chapter we will talk a little bit about multiplication and division. Okay, so what these two children are doing, they are basically counting the number of wheels of these cars and auto rickshaws and bicycles, and they are now all of these cars and auto rickshaws and so on, they are standing behind a traffic light on the street, and so you don't have much time to count essentially the number of wheels. For example, if you want to count the number of wheels in the cars, for example, you would have to go essentially in a car there is basically 4 wheels, so you would have to go essentially 1, 2, 3, 4, and then for the next car 5, 6, 7, 8, for the next car 9, 10, 11, 12, and so on and so forth. And so they are standing here just for a few seconds, so you're going to miss that. I mean, you're going to essentially, your counting is not going to be complete before they have left, right? Now here you need to note that, of course, that the car has 4 wheels, the auto rickshaw has 3 wheels, and the bicycle has 2 wheels. So now she's saying, what are you looking at? And he's saying, I'm counting the wheels of auto rickshaws and bicycles by adding the number of their wheels, meaning that he's not essentially counting, he's adding. Basically he's saying that essentially, for example, in a bicycle there is two wheels. So if there are, for example, 1, 2, 3, and 4 bicycles, then the total number of wheels would be 2 plus a 2 plus a 2 plus a 2, right? But I missed the cars as they had started moving. But now this addition is going to take a little bit of time, because, for example, when you get to the cars, then there is essentially 1, 2, 3, 4, 5, 6, and 7, for example, cars here, and each has 4 wheels. So then you have to go essentially 4 plus 4 plus 4 plus 4 7 times, and then until you have done your addition, the cars have already moved. You cannot count the number of cars, you don't have much time, so this addition is not going to be efficient in all possible situations. We have to come up with a better solution. Now she's saying, okay, I will show you a way of finding the total number of wheels. There were 7 cars and each car had 4 wheels. So the total number of wheels is 7 times 4, meaning 28. And he's asking, how did you do it? She's saying the total number of wheels in a car is, you can of course say essentially a 4 plus 4 plus 4 plus 4 7 times, but an easier and faster way of doing the same thing is to say that it's 7 times 4 instead of 4 plus 4 plus 4 7 times, right? And then he wants to know essentially how she managed to do that. So here is the explanation. Okay, she's saying now that there are basically 4 bicycles. That's the number of bicycles. You have to count them, and each bicycle has 2 wheels. I mean, if you already know this, or you count the number of wheels on a bicycle, and then every other bicycle will have the same number of wheels, right? So then the total number of wheels would be basically a 2 plus a 2 plus a 2 plus a 2 4 times. 4 times because essentially there were 4 bicycles, right? Now if you do this calculation, you will come up with the number 8, meaning 2 plus 2 plus 2 plus 2. Now we are adding 2 for 4 times, right? So another way of saying the same thing is that instead of saying adding 2 for 4 times, we can say that 4 times 2 is equal to 8, or 4 groups of 2 essentially gives 8, or give 8. And of course here we are using the word times in mathematics, instead of the word times, we can use this symbol 4 times, the cross symbol 4 times, and then instead of saying 4 times 2, we can just simply write 4 times 2 is equal to 8, right? So now let's take a look at this on our own sheet. Okay, so what we have here is that we have essentially the total number of bicycles, the total number of bicycles is essentially equal to 4, right? Now each bicycle has 2 wheels, right? So essentially we have 4 bicycles and each bicycle has 2 wheels. As a result, the total number of wheels would be basically essentially 2 wheels for the first bicycle, right, plus another two wheels for the second bicycle, plus another 2 wheels for the third bicycle, plus another 2 wheels for the fourth bicycle. And we know that essentially we know addition, so you know how to do this addition. For the first 2 you have 2 pebbles, for the second 2 you have 2 pebbles, for the third 2 you have 2 pebbles, for the fourth 2 you have 2 pebbles. If you add essentially all of these together, then you can count. It's 1 2 3 4 5 6 7 8. So in total you have 8 pebbles, right? So then the total number of pebbles would be simply 8, right? Okay, so then instead of writing 2 plus 2 plus 2, essentially what this expression means is that essentially it is 2 plus 2 plus 2 plus 2 is equal to 8, and that is essentially 2 plus 2 plus 2 4 times, right? Now instead of writing the same this expression this way, we can essentially write it 4 times 2 is equal to 8, right? And well, it's not, I mean, when I write the expression this way, I haven't changed the nature or the meaning of the expression. I have just rewritten the same expression in the exact same way, meaning that it's just a shorthand way of writing the exact same expression, meaning that now in this case, for example, for this simple calculation, I could write essentially the 4 2's in the limited space that I have here, right? But then suppose that, for example, I were to add essentially 2 to itself 1024 times, then I would have to write essentially a 2 plus 2 plus 2 and so on and so forth, 1024 times is equal to essentially some number, right? The number is not important. The important thing here, what I want to show you, is that essentially that basically that if I were to write out essentially 1024 times, I wouldn't have even enough space over here on my screen or on a piece of paper, basically, right? So then instead of writing essentially this expression, which is not even possible to write in the first place, I'm going to write essentially 1024 times 2 is equal to the same number that we got here, right? And then we will have to essentially to find some way in order to find the answer to this addition, and then the same answer we will use for this multiplication, right? Now which is essentially something interesting in and of itself. We will talk about that as we go along, okay? Now in mathematics, basically what we do is that we, instead of the word times, we can use the cross symbol, right? We can use the cross symbol. which means that instead of writing essentially 4 times 2 in mathematics, I can simply write 4 times 2 is equal to 8. Okay, so then what that means is that instead of writing basically a 2 plus a 2 plus a 2 plus a 2 4 times is equal to 8, I can write 4 times 2 is equal to 8. And you see that essentially the length of this remains the same whatever the number of the numbers that you essentially add together, which is essentially the power of this expression, essentially. Meaning that if I were to write, for example, I don't know, 2, for example, a 16 times now. This is 4 times. Now let's write it as 16 times just to actually see what happens. 2 plus 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 2, that's an 8 times, plus a 2 plus a 2 plus a 2 plus a 2, that's a 12 times, and 2 plus a 2 plus a 2 plus a 2, that's 16 times. That's going to be equal to 32, right? Now instead of, now you see that essentially as I increase the number of the numbers that are involved in the addition, the length of the expression is going to get longer and longer and longer, right? But instead of this expression, now I can write essentially a 16 times a 2 is equal to 32. So you see that the length over here remain the same, right? So that's essentially the actual power behind essentially this type of expression. Although to find the answer, then we'll have to make things a little bit more advanced, and then using those techniques and strategies, we can actually calculate the answer without actually going through the addition itself, basically. Okay, so that's basically that. And that's basically what the girl has explained here for the number of the wheels of the bicycle. She's saying that there are basically 4 bicycles here, and each bicycle has 2 wheels. So then the total number of wheels is basically a 2 plus a 2 plus a 2 4 times, because there is 4 bicycles. And we know that essentially 2 plus a 2 plus a 2 plus a 2 is equal to 8. So which means that we are adding 2 4 times. So 4 times 2 is also equal to 8, or essentially 4 groups of 2 essentially is nothing but an 8 basically. And essentially the word times, we can write it as the cross symbol over here. So instead of writing essentially 4 times 2, we can write 4 times 2, which is essentially the same thing, change of notation. 4 times 2 is equal to 8. Okay, and then we can essentially do the same thing for any object that we find around ourselves. For example, if you were to calculate, for example, the number of the wheels essentially in the auto rickshaws, you can essentially use the same strategy. Now if you were to essentially find the total number of wheels essentially in the auto rickshaws, you could say that essentially the number of auto rickshaws that we had over here was basically 1 and 2. So we have, in total, we have 2 auto rickshaws over here, right? So we have 2 auto rickshaws, and the number of wheels of each auto rickshaw is equal to 3. Well, they have each has essentially 3 wheels. So then the total number of wheels in all the auto rickshaws would be essentially, in one of them we have essentially 3 wheels, and in the second one we have 3 wheels, so we can add them together basically. So 3 plus 3 would be equal to 6, right? So the expression that I have written over here is 3 plus 3 is equal to 6, or 3 plus 3 basically 2 times is equal to 6, right? So instead of writing 3 plus 3 2 times, I can write essentially 2 times 3 2 times 3 is equal to the same number, 6 basically. And then we can change our notation and we can say that 2 times 3 is equal to 6, and that becomes essentially our new expression in terms of multiplication, right? That's basically that's essentially the now in this basically in calculating the total number of wheels of the auto rickshaws in this manner, there is still one problem, and the problem is that you still need to do your counting, meaning that yes, you still need to do your addition in order to come up with the answer for the multiplication, right? Which is still some weak point in our strategy, meaning that if, of course, 3 plus 3 you can calculate, for example, using any strategy, meaning that you could say, for example, we have 3 pebbles here and 3 pebbles here for the first and the second auto rickshaw. Then I add them together, I put them together, then I count 1, 2, 3, 4, 5, 6, and so then 3 plus 3 is equal to 6, and so then 2 times 3 is equal to 6, right? But then the problem here is that basically that essentially this strategy has its own shortcomings, meaning that here essentially you're adding 3 plus 3 2 times. Now what if you were to add essentially 3 plus 3 1,000 times, or 2,000 times, or even a greater number of times? Then of course it would not be easy to do the addition, right? We still need to find some way in order to not to have to do the addition manually, okay? And then that would be essentially the power of essentially multiplication, which we will see as we go along basically, okay? So that's all the way up to here. Now over here basically we see that that the same thing has been done for cars, meaning that, for example, the number of cars is in this case, for example, I think 7, if I'm not mistaken. We have 1, 2, 3, 4, 5, 6, and 7. We have 7 cars here, and the number of wheels in each car is 4. So then we have essentially 4 plus 4 plus 4 plus 4 plus 4 plus 4 7 times, which is equal to 28, which means that essentially 4 plus 4 plus 4 7 times, which means 7 times 4 is 28, or you could say essentially 7 groups of 4 is essentially 28, or essentially 7 times 4 is equal to 28, right? Or basically you can do the exact same number of things, essentially, for example, for butterflies. So essentially we have essentially 4 butterflies over here, and the number of wings in each butterfly is 2. So the total number of wings would be excuse me, that's 3 butterflies. So that's essentially 2 plus 2 plus 2 3 times, which is equal to 6. So, or 3 groups of 2 is nothing but 6, or essentially 3 times 2 is equal to 6, or 3 2s are 6, all mean the same thing. Instead of writing essentially 2 plus 2 plus 2, you can write 3 groups of 2, or you can say 3 times 2, or essentially you can say 3 2s are 6, which means that essentially 3 times 2 is equal to 6. Or, for example, to calculate the number of legs in these octopuses. So that essentially we have 2 octopuses over here. The number of legs in each octopus is 6, 3, 6, and 8. So each octopus has 8 legs. So then the total number of legs in both the octopuses would be essentially 8 plus 8, which is equal to 16, right? So then instead of saying essentially 8 plus 8, we can say essentially two groups of 8 together would be a 16. Or essentially 2 times 8 is 16. Or 2 8s are 16, right? Or essentially you can write then, finally you can write 2 times 8 is equal to 16. Or here basically what we can say is that, for example, we have these lines of soldiers, and the number of lines is 1, 2, 3, and 4. We have 4 lines over here. So the number of soldiers in each line is basically 1, 2, 3. Make this a little bit bigger so that we can count. So we have in each line we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 10. So in each line we have essentially 10 soldiers. So number of soldiers in each line is 10, and we have essentially 4 lines. So then the total number of soldiers would be basically 10 plus a 10 plus a 10 plus a 10 4 times, because we have 4 lines, right? And so based on this, we can say that essentially 4 times 10 is equal to 40, and or instead of saying 4 times 10, we could say essentially 4 tens are 40. Or essentially we can mathematically we can write 4 times 10. 4 times 10 is equal to 40, right? So that's basically another example for multiplication, right? Now, one thing that I want you to note here and to wait for as we go along in these videos, which is essentially not too obvious. It's really not even explained in normal basically school curriculum, is that essentially this strategy that we have put together over here is, of course, it's strong. I mean, it is powerful in and of itself, but still it has one weakness. It has one problem that we haven't solved yet, meaning that essentially for calculating the number of soldiers over here, we still have to do addition, right? Meaning that still have, in order to come up with this expression over here, meaning essentially 4 times 10, you just simply don't know what that is, right? The only way that you can know what is 4 times 10 is to go through this addition, which is 10 plus 10 plus 10 plus 10, which you need to do manually, and then find the answer over here, and then transfer the answer to this expression over here, right? And of course, you know that addition is going to take a little bit of time, right? Meaning that of course here 10 plus 10 plus 10 4 times, it's easy to calculate. You can do it in a couple of seconds, right? But then if you were to do essentially 10 plus 10 plus 10 a couple of thousand times, then it would take you probably forever to do the calculation. So as we go along, we have to think of some way so that we can keep the same strategy, but then we don't have to do the addition manually. That's something that we will figure out as we go essentially as we go along in these videos. Thank you.